Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. Here in this video, I am going to explain about the loss of head due to sudden expansion of the pipe. As shown in the figure, we are having a pipe. Its initial area is A1 and suddenly its area increased and A1 increased to A2. The velocity of water flowing through pipe at one section is your V1. The velocity at the outlet, it is V2. We have seen that due to the increase of diameter, there is a loss of energy takes place. We have pressure is directly proportional to area. If area of the cross section of pipe increases, pressure increases. If area of the cross section of pipe decreases, then pressure decreases. In earlier at part 1, there is a flow of liquid takes place where area and velocity as A1 and V1. The area decreased, so velocity is more. Now we are going to expand the outlet of the pipe. We are going to increase the area as A2. Suddenly, the velocity will be decreased. Why this is occurring? As pressure energy increases, velocity decreases. We have seen that there is a surface, there is a curved surface, and that curved surface from this corner point to that of the expansion process. There is a curve, and that curve will be showing you that there is a sudden expansion of the pipe. There will be a turbulent flow takes place or eddy formation takes place. We have seen that due to the sudden expansion of pipe, this is the area, this area where there is a force vortex takes place. Force vortex means there is a energy with which the water is rotating at that place, and due to that some amount of water foams are created, and due to that the loss of energy takes place in the pipe, that is known as your kinetic energy loss. So at this point and this point there is a loss of energy takes place. So we are going to see that at the increase of area takes place, there is a loss of pressure energy takes place. There is a increase of pressure energy takes place, but there is a kinetic energy loss takes place. As shown in the figure, we are having a figure. There we are going to see that how the forces are under the control of volume. As shown in this is the initial arrow marks. These arrow marks suggesting that the water is at the pressure P1, but while it is moving through the passage section 2, there is a pressure P2 and area T2. If V1 is the velocity of water at inlet, V2 is the velocity at the outlet or exit, then the loss of energy or that loss of kinetic energy in the pipe can be given as the function of velocity. The velocity function can be given as hf is equal to V1 minus V2 whole square divided by 2g. There is a kinetic head loss takes place. In this way, we are going to calculate the loss of head due to friction, and that is a minor losses in pipe due to sudden expansion. So this is the very vital case. While we are going to see the turbulent flow is going to be takes place in the sudden expansion of pipe. Due to turbulent flow, due to change in area of the cross section of the pipe, there is a flow takes place, and that flow is known as a turbulent flow. Due to turbulent flow, the layers are crossing each other, and thereby there is a eddy formation takes place, and due to that eddies formation, some amount of kinetic energy loss takes place as well as pressure energy takes place. In this way, we are going to conclude that the loss of head due to sudden expansion of pipe is in terms of velocity head, and velocity head or kinetic head is equal to V1 minus V2 square by 2g. Thank you.